In this section, we want to look at how functions can be transformed. If you think about any type of a function or any type of a graph, we want to be able to move that graph around. We can move it up, down, we can move it right, left, we can stretch it, make it bigger, we can shrink it, make it smaller, we can reflect it, we can flip it over some value. Okay, so those are the things that we want to do to any of our functions. Okay, so what we have is our function notation. Remember, function notation just means that I have f of x to represent the function. So really what we want to look at is how can we move that function, and where we put the value will determine, how we're going to move it. So for example, I could place a value in front of my function. So I could place that value in front, being multiplied. We're going to call that value a. If I place a value in front of the function being multiplied, think about it as I'm going to take something, I'm going to amplify it. Okay, so I'm going to make the whole function bigger, but I could also make the whole function smaller. So that a in front is going to help us stretch or shrink the function. Okay, so if it's a positive a and that a is greater than 1, we're going to say it's going to stretch the function. If it is less than 1 but greater than 0, we're going to say it's going to shrink the function. Okay. Now, I could also take that function and put a negative out in front. So a negative meaning it's going to do the opposite. In our case, when we transform something, a negative is actually going to reflect that function. So I can reflect it where instead of everything being on the top, it's going to now be on the bottom. So I reflect something that goes up and down to now it's going to go down to up. Okay, so when we reflect, we're going to reflect over the x-axis. Okay, so that's what would happen if I put a number in front or if I put a negative out in front of our function. Okay, that would represent our a. Remember, it's being multiplied in front. So let me put that there. It's being multiplied in front of that function. Okay, now I could also take this function and I could, instead of multiplying, I could add something to it. Now I've got two places really that I could add. I could add inside the function or outside the function. So let's say that we were to put something either adding or subtracting inside of this function. Okay, so we use our h to represent a horizontal motion. So think about if you were going to move something horizontally, you can move it to the right or to the left. Okay, so that h, if I were to add or subtract inside the function, okay, so we're going to add or subtract inside the function, it's going to move this to the right or to the left. It's a horizontal motion. Okay, and it's actually going to be opposite of what you think. So for example, normally when I say, okay, I'm going to add 3, I would think, okay, well, it's going to go to the right because to the right is positive numbers. But it's actually going to be opposite, meaning that if I put a plus 3 inside, it's actually going to move to the left, versus if I put a negative inside, it's actually then going to move to the right. Okay, so it's going to move left and right when I'm adding or subtracting inside the function, but it's opposite of what you would think. It's opposite of what the number line is going to show. Right? So the last place that I could kind of put something here would be on the outside of my function. So let's say we put a plus or a minus outside of that function. So think about the motions that we've already done. We've flipped it over, we've stretched it, we've shrank it, we've moved it to the right, moved it to the left. So the only other places for it to go would to be going up and down. So remember, we're going to be adding and subtracting outside of the function this time. And that's going to represent some sort of a movement up and down. So it's exactly what you think. So if we add k to the outside, we're going to move up. If we subtract k, we're going to be moving down. Okay, so it's kind of a lot going on, but really it's pretty simple. I just need to memorize where the number is, what type of motion it will be. So let's look at a couple of examples here. So looking at this first example here, I see that I've got a number on the outside. So a number on the outside, that's going to be our a. So the question is, well, is it positive or negative? It's positive. Is it greater than 1? So this is going to stretch the function by 3. So it's going to be 3 times larger, right? Then I notice that I've got a minus 2 on the inside. So I'm subtracting on the inside. So it's going to be my h, and it's negative, so I'm going to be moving to the right 2 units. Okay, then I notice I've got a 4 on the outside of the function, so I'm adding 4, which means I'm going to be moving up 4. Okay, so hopefully now it makes a little bit more sense. It's all about the location. Okay, so let's look at this next one. I've got a negative out in front. A negative out in front is going to reflect over that x-axis. Okay. Then I've got a plus 7 inside, which is going to move it to the left, 7. Then I've got a minus 1 outside, which is going to make it move down 1. Okay, so hopefully we're kind of getting the hang of it here. Let's look at our next one. The only thing I have here is this minus 3, and a minus 3 inside is going to be moving it to the right 3. So just because all these things could happen doesn't mean they all have to happen. Okay, let's look at this last one here. I've got a plus 6 on the outside. This is going to move up 6 units. Okay, so now we've kind of seen how we can find the location of the number, and it's going to tell us how we're going to move the function. So the last thing is, not only do we need to describe what's happening, but then we actually need to move the graph to what we said it's going to do. So let's look at this first problem where we describe it and then actually graph it. So we've got a minus 1 inside, so that's going to make us move to the right 1. We've got a plus 4, which is going to make us move up 4. Okay, so now I'm going to take that whole function, this whole function here, and move it to the right and up. Okay, so I'm going to move it right 1, up 4. 1, 2, 3, 4. So I'd have something like that. I'm just moving each point and then kind of making the graph look like what it would be. I'm going to move right 1, up 1, 2, 3, 4. So it'd be something like that. So now I can see from the old function to our new function that we've moved right and up. All right, next one here. Let's see, we're going to reflect this graph. And then we're going to move to the left 2, and then we're going to move down 1. So we're going to take this and we're going to reflect it over the x-axis. So all that means is, like, say this down here is negative 4, it's now going to become positive 4. And then this point is down 2, it's going to go up 2. And I'm just going to do a little sketch. We'll go back and erase that in a minute. But just so we can see where it is after it's been reflected. Now let's actually move that left 2 and down 1. So I'm going to go left 2, down 1. Left, oh. I'm going to go left 2, down 1. Oh, I did not draw that very good, but right, so it would look in the end something like that pink function there. All right, so it's okay if at every point you have to put the new point and all that. I typically can move right, left, and up, down kind of all in one motion, but if I'm reflecting or stretching, then I have to do that kind of separately, and then I need to move it right, left, up, down. Okay, so now we should be able to identify what is happening to the function, how is it going to transform, and actually move a graph in the direction of the transformation.